In the last few videos, we focused on naming alkanes, molecules that have just carbon-carbon single bonds, as well as haloalkanes, molecules that have carbon-carbon single bonds and have at least one halogen atom. We also looked at naming alkenes, and those videos that corresponded to such exercises were videos 310, 311, and 312. Now we are going to apply the information we learned in those three videos toward the nomenclature of alkynes, seeing that there's a lot of parallels between how to name these various types of molecules. By the end of this video, you will be able to name a molecule such as the one that we see here. Let's go ahead and dig into this topic further. Now let's say you're looking at this on the screen and having a bit of deja vu. It's no coincidence. We used this same information in the last video where we named alkenes. Really, the major difference between naming alkenes and naming alkynes here is how we name the parent chain. So with alkanes, the ending was ane. With alkenes, it was ene. And with alkynes, it needs to be yne. Just like with alkenes, we will number the longest carbon chain starting from the end closer to the alkyne group, just like we started closer to the alkene group when we were naming alkenes. In other words, don't look for where the branch that comes off closest to the end of the parent chain is. Instead, look for where the alkene or alkyne group is within the longest carbon chain. You want to put that alkene group or alkyne as close to the end of the longest chain as possible. And then make sure that you're listing where the alkene or alkyne, in our case it'll be an alkyne group for this video, is located. In other words, if you see when you number the longest carbon chain starting at the end closer to the alkyne group, that the alkyne starts at carbon 4 and ends at carbon 5, you would call that 4 dash whatever the alkyne parent name was. So 4 dash decyne as the name of the molecule. And then, as before, fill in the branches and the locations of those branches, such as isopropyl, butyl, etc., all those things that have a YL suffix to indicate that they are branches coming out of the parent chain. Fill those in according to the same criteria that we've used over and over again. In the case of cis-trans geometry, we haven't gone over that yet in any of the videos, but that is never going to be applicable for alkynes because of the molecular geometry of alkynes being linear. So cis-trans geometry we will get into later for alkenes in a future video, but we will never be talking about that for alkynes because it's just not relevant. So let's apply this toward an example problem. We will use the example problem that we had on the title slide there a couple of minutes ago. I'm going to go ahead and zoom out on our general information, and I will be bringing into the screen the structure that we will focus on here. We begin to name this molecule by finding the longest carbon chain. Remember that the longest carbon chain has to include the carbons of the alkyne group. And keep in mind here, when we have the alkyne group, that this may look a little different than what you're used to in a line angle formula, because usually we think of ends and bends in the line representing carbon atoms. But here in the case of an alkyne, since the geometry at a carbon atom of an alkyne is linear, we draw that as linear here to reflect that. And so the intersection here of the triple bond and the single bond indicates there is a carbon atom there and a carbon atom here where I'm highlighting. Do keep that in mind as you're going through these types of problems. Finding our longest carbon chain, the way I like to go about that is I look at where the ends of the molecule are, where the carbon atoms are that are the ends of the line. Those represent possible starting points and ending points for the longest carbon chain. We find the longest pathway through to connect one of those yellow ends to another yellow end, and keep in mind that that pathway has to pass through both carbons of the alkyne group. So in other words, in the case of this molecule, we need to start from one of these yellow dots over here, passing through the molecule to end up at one of the two yellow dots at the other end of the molecule, passing through that alkyne group en route. So how do we go about doing that? We remember that to find the longest carbon chain, we trace through the molecule, making the longest pathway through that we can get without having to lift our pencil and without having to backtrack. I encourage you to hit pause here, take a moment to shuffle through and do some trial and error to sort out the longest carbon chain, then hit play to see if you came up with the same answer that I did. All right, here's how I found the longest carbon chain. I started right here, came up through here, here, here. That was the longest pathway to get through the left part of the molecule here. Because if you're coming through this way, it would have been a shorter route to get to this point. Then we come on through, through here. And we get to this point, and you may have struggled here saying, should I go this way or should I go this way? It doesn't matter, because both of these paths lead to groups that are totally identical. We have a CH2 group here, CH2 group here, CH3 group here, CH3 group here, totally identical. So it doesn't matter which pathway you take through there. So I'm just going to go this route, but you could have gone the alternative and gone up through here. You would come up with the same IUPAC name in the end as I if you have done things correctly. Now, to number the longest carbon chain, always, always, always begin at the end closer to the beginning of the alkene or the beginning of the alkyne. In this case, it's an alkyne group. And we'll start numbering from the end closer to that, figuring out where the end closer to it is. If we start from this, it's going to be 1, 2, 3, 4. Position 4 is where the alkyne group would start. If we come from this side, we go 1, 2, 3, 4, 5. Position 5 is where the alkyne group would start. So the correct way to do it is to start from this end, 1, 2, 3, 4, 5, 6, 7, 8, 9, coming up with all of the carbons of that longest carbon chain. Keeping in mind, again, that the intersection of the triple bond and the single bond represents a carbon, so I put a 4 there and a 5 here. With this being the longest carbon chain, the parent name of this molecule is going to be non-yne, N-O-N-Y-N-E, and at position 4 is where the alkyne group starts, right here. So we call this 4-non-yne. Also, a synonym for that, if you would prefer, you could call it non-4-YNE. Some people prefer to name it that way because it puts the number as close to the group name alkyne as possible. But it doesn't matter which of these you plug in as the parent name. Either one will work as the last part of the name for this molecule. With everything that we've highlighted in red in the molecule now nailed down, we focus on naming the branches or the so-called substituents that come off of that red parent chain. So we have a bromine group there, we have a 2-carbon branch coming off here, and we have a 2-carbon branch coming off here. We call those 2-carbon branches because what we have highlighted in red has already all been accounted for. So we've accounted for carbon number 6 right here we've highlighted, but coming off of that there's a carbon here and a carbon here, so that's what we call a 2-carbon branch. A 2-carbon branch is referred to as an ethyl branch, so we refer to this in detail as a 6-ethyl branch because it's at carbon number 6 of the parent chain. Number 6 is there in red, that we have 2 carbons coming off or branching off, so we call that 6-ethyl. We also have an ethyl branch at position 3 because we have our parent chain here in pink, and then we have carbon 1 and carbon 2, so 2 carbons in a chain coming off and branching off of that, so we'd call that an ethyl group as well, and to be specifically 3-ethyl because it is at position 3 of the longest carbon chain where that comes off. And then at position 8 here, we'd have 8-bromo, B-R-O-M-O, indicating the branch coming off there. Now, plugging this all in, the parent name we said was 4-non-yne or non-4-yne, whichever you prefer, and we enter the branches based on alphabetical order, where bromine comes before ethyl in the alphabet, and so therefore bromine would be listed first in our prefixes. So we'd call this 8-bromo, separating numbers from letters using dashes, dash, and then we have an ethyl group at position 3 and an ethyl group at position 6, so we refer to that as a diethyl group, and we have to indicate where both of the ethyl groups are located. There's one at position 3 and one at position 6, therefore we put 3, 6 dash di, indicating there are 2 of the group ethyl, and then we fill in the 4-non-yne part, so I put ethyl dash 4 dash non-yne, Y-N-E as the suffix there to indicate that it is an alkyne. That is an essential thing to remember as you're writing this down. Don't get in a hurry and enter the suffix there wrong on the parent name. The Y-N-E is critical there. So this would give us our full IUPAC name for this molecule.